Hi, everyone. Thanks for being here. I'm very happy to be presenting today the project that I work on in my team at Oracle, and that we recently released open source. So that's why we want to talk about it, and for sure there would be interest. So a few words about me first. 5 years ago, I was defending my thesis in this exact room. There was a lot less people in the room. It was less intimidating. Also, half of the people in the room were my family and friends, and I knew most of them. But I'll do my best to be as good as during my PhD defense today. In the past 3 years, I worked at Oracle as a senior AI researcher and database AI research team. So for this presentation, it's going to be more of a workshop. I will quickly give some backgrounds on large language models first to make sure everyone knows the most basic blocks. And then I will introduce Agent Spec, the project the core of this presentation. But most of the time, I want to spend it on a demo where we'll have a notebook and some code and guide you through the code. I'll share a link for everyone to also download this code and be able to run it themselves if you want, but it's optional. You can interrupt me with question. Just raise your hand. I will try to see it, and if I don't see you, make some noise. No problem. So first, background. How to train a large language models. So you probably all have talked to some chatbots or use large language models, but what really gets into this? The first stage is pre-training, where we use a lot of data and we train a language model simply to be a predictor of the next word coming up after some initial set of text. So for this can be used as we pass half of a Wikipedia page and use an LLM to predict what would be the text of the second half of that Wikipedia page. But when we have such a large language model, if we ask a question to the large language model, it's not guaranteed that the large language model will answer the question. Maybe the large language model will think this question is part of a long list of questions, and then will generate a second question and a third question, and it's useless because we don't get the answer to our questions. So the second thing that happens to make a large language model useful as agents that can help us is this concept of prompting. And the prompting would be to put a text in front of the large language model that starts with what's called a system prompt, which is a description of what the agent is and what behavior it should have. Then happens a user message. So this system prompt also says, below is the conversation between a user and an agent. And then the next text is a question by a user, and then it says agent, and now we use the large language model to complete that text. When using the large language model in that sense, the natural things to do for the large language models is to generate a response of the agent to the question of the user. So that's a way to make a large language model to be something conversational. To make sure, so when we have something that carries conversation, often conversation in the real world, if we just predict what are conversations, they will not always be helpful. Someone asks, can you help me with that? And the other person reply, no, I don't have time, sorry. And we don't want LLMs that predict that the answer would be, no, I don't have time, sorry. We want an LLM that acts as an agent and help us. So that's why there are the next two phases in the training, which are fine-tuning for following instructions. So here, this was done with also a rather large data set of this examples conversation where the agent follows the instructions and is obedient and helpful to whatever the needs of the user are. And the second phase, the last phase of training, the third phase, alignment, often called, is further improving the agent to make sure it's as helpful as possible when it's not only an agent that follows instruction and try to help, but also follows instruction correctly and try to help correctly. This phase, the first technique that was really popular for this phase of the training was called reinforcement learning from human feedback. And the core of this were to show to human annotators two possible answers by a conversational LLM, and let the human annotator label which of these two answers were the best. And then with some reinforcement learning technique, retrain the model, update the predictions of the models so that it imitates more often the more helpful answers. Okay, so the next step after this to really make a helpful agent here, previously I only talked about agents that carry conversation and try to help you through conversation. But to build an agent that really makes action on the world, like does things for us, like send an email, add an event in my calendar, etc. The most common technique for this is called react. React is for reason and act. So in that case, to perform the technique, the agent, this conversational LLM is prompted with description of what's called tools. Tools are external functions that the agent will be able to invoke. So in the system prompt, there are description of the tools that say the list of tools available, but also arguments for these tools and what these tools do. And then it looks like the image on the right. The agent will be made to reason. So that's why it predicts the text thoughts. Then it's made to act. And what you see in act is that the agent selects a tool. Here in that case, act 1, it selects the tool for search. And it passes some arguments to this tool. After the LLM generate that text, invoking the tool search with the search arguments, the generation from the LLM just stops, and some method executes this tool, and whatever result of that tool is then appended to the prompt or the conversation with the agent, such that the agent reads it and then decides what to do next. And the last bit of context that I wanted to mention is the concept of a model context protocol, which is an open source standard that is getting more and more popular to help connect tools to agents. So before this standard, every agent implementation would implement their own way of making tools available to an agent. But as more and more applications or service or APIs follow this MCP protocol, it becomes a lot more easy to have any frameworks to develop agent and some existing MCP server or developing our own MCP server, and they would connect well, they would work well together. Okay, any question so far? Go ahead.
Yeah, so how am I supposed to imagine the difference between MCP and the API? Because the API is already kind of like a set of actions I can do with description, right?
Yeah, so typically, when you say an API, you mean any arbitrary web API.
Yeah, like let's say you have an Open API spec. So you have basically like documentation of which can do what. So Open API spec is one way to represent APIs. So what was needed for agents is any arbitrary API doesn't answer the question to show this description of the API in one unified way to the LLMs, such that LLMs can be fine-tuned, optimized to understand and act on this way of representing the API. Open API specifications could have been a good candidate instead of MCP. MCP has some extra things like data sources or some contextual information, some extra prompts that go to the agent, but overall they are quite similar. Yeah. Okay, I'll present agent specs now. I have a typo in the title. It should be Open Agent Spec. Sorry. The context first. In the past few years, we have seen a proliferation of frameworks to develop agents. All of these icons on the right are some examples. Myself doesn't know 80% of them. Or more. There are more than hundreds new startups or tools or open source projects to help you develop agents. But one weakness of these environments in which agents are being developed is that if you develop agent in one framework, you cannot easily reuse whatever you developed in this framework if suddenly, for some X or Y reason, you need to use another framework. So what we developed with Open Agent Specs is an idea that helps bridge this gap between all of these hundreds of frameworks. In the past with deep learning, something similar emerged. The ONNX, for Open Neural Network Exchange, is a way that many machine learning, deep learning frameworks created models, and then ONNX is a format to exchange models between one framework to another framework for deep learning. So, for example, a model would be developed in TensorFlow, then exported to ONNX, and then re-imported in another framework like Torch. So, with Open Agent Specs, we want to do something similar to what ONNX did for deep learning, but do this for the development of agents. So in one sentence, to describe Open Agent Specs, it's a framework agnostic configuration language to define AI agents and flows. So I think in previous workshop, there was already this description that there are on one side AI agents, and on the other side, similar AI applications, flows that go through different steps to execute some business logic. So our solution is a framework agnostic because it's simply a configuration language that is independent from any of the other frameworks. And then the simple implementation of what we call runtime adapters. I will explain more in the next slides what that is. These runtime adapters can take an agent spec configuration and then prepare it, adapt it to be executed within another agent development frameworks. That has the advantage of reproducibility and exchangeability. Reproducibility because this configuration, if you cannot run it again with the same agent framework, you can reproduce the same result, run the same behavior of the agent in another framework. And exchangeability because this format of configuration is purely text-based. I mean, what we use typically is a JSON to represent these agents. And thus, it's easier to save that in a database or share it, etc. And then Agent Spec comes with a lot of pre-built components that are in this configuration. And these components, thanks to the runtime adapters, can be executed with the different agent framework like LangGraph or AutoGen or CrewAI. And then thanks to this, we have more modularity and reusability because things that are developed through this Agent Spec framework are now reusable across different frameworks. I forgot to say that runtime adapters also allow you to develop in one framework and convert what was developed in that framework to an agent specification such that you can then use it in another framework. All right, so more details. Here in the center, you see an example. It's very simplified, and there are missing parts, of course, of one agent spec representation that represents a retrieval-augmented generation agent. And then on the right of this, so this is purely a representation of an agent. With that representation, nothing can happen. We need to take the components that are on the right, what are called the runtime adapters. And here I show 3 examples that are the most advanced. You will see that we are developing them at the moment. And these runtime adapters read that configuration, adapt it to the different agent framework, and then can execute it. Okay. So a quick word is that the two projects, Agent Specs and also Wayflow is one of the most advanced runtime adapters for Agent Specs that we are developing. These 2 projects are open source, and we regularly release new versions with new functionality. And you should be able to install them very easily with just either pulling the code and installing from source or installing from the Python package index. All right, any question so far? Otherwise, I'll jump into some example code and some example of the functionalities of Agent Spec. All right, that's good. So I mentioned before agents that are able to use tools. That's the most common thing that we want in an agent development framework. So here is in a little bit simplified manner what it looks like using Agent Spec. So more precisely, the code is written in Python. It's because the first thing we developed for Agent Spec is a Python SDK that lets you write a simple Python code to specify the configurations that you need. So on the right is the definition of a server tool. I'll explain a bit more in detail right after why we call that a server tool. And on the left, so this tool defines as a name, as a description to define what the tool does, and it also has inputs and outputs to define how to invoke that tool and what would be the result. All of this metadata is necessary to correctly include this metadata in the prompt such that the LLM predicting the completion has a chance to correctly predict the invocation of the tool with the right arguments. And then when building an agent on the left, you see that the agent is given a name, a system prompt for custom instructions to describe the behavior of this agent, and then a list of tools. And additionally, it's being given a large language configuration to connect to a large language model. So to say more about tools, we included in Agent Spec multiple types of tools. First, the tools coming from an MCP server. So this is somehow the easiest thing to leverage. Just having an MCP server that exposes a collection of tools, and then connecting the agent to the tools of this MCP server. For the configuration in that case would contain the name, description, inputs, and outputs of the tools, but also to which URL to connect to the MCP server. The second types of tools we are providing is remote tools. So you asked about APIs before. This is also something that can easily be done with Agent Spec. If you have an API that you want to invoke, I will also show this during the demo. One of the best things to use is this remote tool, where we simply configure the details of what API request to perform. And it will be whenever the agent makes the decision to invoke that tool with some arguments, this web request will be done. The third type of tool we support is client tools. In that case, client tools is that the agent will not be responsible to invoke the tool, but the client will be. So when using a client tool, the agent will just stop execution, provides to the user which tool the agent wanted to invoke with which arguments, and the user, the client, is responsible to do the invocation of the tool and tell back to the agent what is the result of that tool. And the server tool is a tool that runs at runtime in the runtime of the agent. To be able to execute such a tool, the agent also needs to know about the implementation of this tool to be able to execute it. All right. I talked about agents, but the second part that is pretty common in AI agentic framework are the concept of flows. So one of the decisions we took in Agent Spec makes Agent Spec quite different from other framework is to split between control edges and data edges, where control flow edges are simply which nodes follow each other. And for example, on this diagram, the arrows I drew are simply these control flow edges, where it will start from the start node, then go to the LLM node, then go to a tool node. I'll explain a bit more what these are, but this is pretty simple. Then go to a branching node, and then there are two control flow edges out of the branching node that either leads to the end node or come back to the first node of the flow. And this second part is data flow, where when we have a complex sequence of nodes being executed, probably the node number 5 needs to receive data from 3 nodes prior to it. And that's why we separate control flow and data flow, how data is exchanged as outputs of some nodes to become the inputs of the next nodes, and which is different in general from the order in which nodes are being executed.
Okay, here is a code example. So it's slightly more complicated than an agent with a single tool. And starting from the left, we define a start node, which the start node does nothing in the flow. It's simply defining what are the inputs expected by this flow. And so it defines inputs. Then a tool node. So we have this concept of tool that agents can execute. We created a tool node in Agent Spec where the same tool, instead of being given to an agent, it can be reused inside a flow, and this node of the flow will be the execution of that tool. Then a second node is the LLM node. LLM node, as the name suggests, is going to be about sending a prompt to large language models and doing something with the text generated by this model. Finally, an end node, which similarly to the start node being for defining the inputs of the flow, the end node is used to define what outputs a flow will have. On the right, the two types of edges, control flow edges and data edges. And finally, with the list of nodes and the two lists of edges, we can define the flow. So to come back to what I was describing earlier, Agent Spec. So this code you see here is Python code written with the SDK, the Python SDK for Agent Spec, which is called PyAgent Spec. And the Agent Spec format in itself, without using the SDK, can be either use of JSON or YAML, but here on the slide, you see a JSON representation. And for example, I mean, at the top right, you would see the definition of the flow, which has the list of nodes, inputs and outputs, followed by the control flow definition that defines the different edges, the data, and then below the data flow definition that defines how data is passed. On the bottom, you see some definition of a node. For example, if you see the line component type LLM node, in practice, this is not going to be code that you write or even you read as a human. That's why we have the Python SDK that is much nicer to use to help you generate this. Something I want to point to in this configuration is what appears in yellow are a reference to components. So that's why at the bottom you see reference components, which is all of the components that are referenced in different parts of the configuration, because it quite often happens that when we create search configuration, we want to reuse the same node or the same tool or the same agent in multiple parts of this configuration. So this, instead of growing infinitely the size of the configuration, we use this reference object to keep the size of the configuration as simple as possible. All right, we also support in Agent Spec multiple functionalities for composability and also to be able to build a multi-agent system. So because we really want to make it that some components are developed and then they can be reused as easily as possible. For example, we have the concept of a flow in a flow. This is mostly useful when you want to build a very complex workflow, which is first this complex workflow, then this second complex workflow, then this third complex workflow. Instead, you don't have to build a single workflow. You can create independent subflows that are that you can run and test separately, and then combine them using the concept of subflow. We can also put an agent in flows. This is one of the manners in which someone can implement a multi-agent system where some nodes would be an agent, and then depending on the decision of this agent, the next node would be could be a simple prompt or could be a second agent performing a second task. Thirdly, we have the concept of flow in agent, where the same way agent call tools, one tool can be defined as a flow, which performs some complex logic, and this flow given to an agent will be invoked as in the same manner that the agent invokes tools. And finally, we also included in Agent Spec some standard multi-agent system like a Swarm or the manager worker pattern. And we currently are work in progress to bring the A2A protocol. So which is some protocol a bit similar to the ideas of MCP to standardize how multi-agent systems communicate. I'm reaching soon the end of the presentation. Any question so far? Go ahead.
So once you have the representation in the one you like JSON format,
yeah,
you can then convert that one to something that would work in Langflow or another agent framework.
Yeah, exactly.
Can you also go the other way around from like the agent framework to this representation, then go to another one?
Yeah, not. This is a more challenging direction to convert. So we will not support arbitrary implementation in LangChain, but the most standard LangChain implementation or the most standard AutoGen implementation, we will be able to convert it to an agent specification. Yeah, that's at the very beginning. Yeah. Okay. Here the arrows goes both ways. Yeah. So because you can implement something with LangGraph and then out of this have a, so LangGraph is a bit similar to this flow concept that I was describing, where there are different nodes that communicate to another. But it's not fully perfect. The direction executing with LangGraph is pretty easy, but the direction extracting from LangGraph an agent spec is harder. Go ahead.
How will you handle changing specifications? For example, if LangGraph changes their setup completely, is it more like on you, or support a certain version and they have to follow?
Okay, in practice, when you provide a software library to developers, you don't want to completely change it from one version to the next. But if one framework completely changes, then the smaller library, which is the adapter, the agent spec adapter for that framework, will also need to be updated similarly. Yes.
Yeah, so you mentioned the client tool, server tool, and MCP tool.
Yeah.
And my question is, why do these other tools like remote client and server, could they also have been MCP servers? Or is there a particular reason why it wouldn't make sense for such a tool to be MCP?
So here are some reasons. There is already an API that exists out there, which is not an MCP server. So how do you connect to that API? And that's why we provide the remote tool to make it the simplest way to connect to that API. But I will actually show in the demo that you can also create yourself an MCP server that has a tool that connect to that API, and then all the tools become MCP tools. Yeah.
Okay. So it's kind of just to make it your life a bit easier.
Yeah, to help developers develop these tools. Yeah. Okay. I didn't talk about everything. There is many different component types in Open Agent Spec. Things that I didn't mention are, for example, the input message node and output message node. When the flow will pause to give some information to a user or make a request for information, that's what would be used. I will show in the demo the map node, which is a node to just iterate over a list type input. Things that are not nodes of flows in Agent Spec are also the config objects, which are configurations for how to connect to the different LLM providers and the different types of tool. And then property is the object from Agent Spec where we define the types of input outputs. It's either input outputs of nodes or input outputs of the tools. Yeah. Okay, a final slide about Open Agent Spec before I change to the demo. We recently published a technical report that contains some benchmark. The idea of the Agent Spec is not, it doesn't invent new things about agent or train a new model. No, it's about defining your agents. So the idea of this benchmark was simply to prove that by creating this Agent Spec configuration,
and then executing it with the runtime adapters, we can develop the same state-of-the-art AI agents as with any other runtimes of or implementation of agents. So we found small differences with the same Open Agent Spec configuration. We found small differences depending on the runtime that's being used, because obviously the runtimes they are optimized for some specific use cases. But overall, we found that this one good quality agent spec configuration leads to good results with all of the runtime adapters on various benchmark. The simple QA is a question answering benchmark using tools to do research, to do search. Bird SQL is a benchmark for generating a SQL query, and then a Tortu bench is a benchmark where a simulation of a user answers question and make a request, and the agent needs to help the user fulfill. It's like the simulation of a support agent that needs to take action that a user asks for. Okay. Now I will jump to the demo after this. Some motivating word for why is it interesting to try Agent Spec, because it's a framework agent agnostic. You would have a description of agents that are in a JSON format and are more easily shareable. It's open source, so you can check the code and improve it or tweak it the way you want it to be. There are many built-in components that work nicely out of the box and helps you achieve things quickly. It supports most types of LLM models, and it has a very nice documentation and guides to use it. And finally, you can develop any state-of-the-art agent with that as you want. Okay. Any questions so far? Again? No. So for the demo, the LauzHack team was very nice to create a repository on their GitHub. So if you just Google LauzHack GitHub, you will find it. It's named Oracle Agent Spec Workshop 2025. And you can clone this, and the setup is pretty easy. There is a good chance that you are able to execute things at the same speed I am. So, all right. So for the demo, I'll go through 4 small examples. The first one is structure generation with a large language model, which is generating data with a desired format. Then I show the map node, which is executing the same flow n times on the list input. And then I'll show the React style agent with the different tools, either a server tool or a remote tool, and also with MCP an MCP server. So here I'm ignoring warning because there are some warnings that are not very interesting to discuss during the presentation. So the first thing to start before before being able to develop an agent or a flow is to have the configuration to some LLM. So here I'm using Ollama. It's pretty convenient to have a small LLM locally running on your machine. But there is the guide here that you can open if you want to run the same notebook with another LLM, like some OpenAI LLM or something you host yourself with a VLLM. I don't know what you typically do. This is also possible. In this, to configure, I simply need the URL and the model ID. Here, this URL works because I'm running it locally at this port. And then you can also specify optionally some generation config, limiting the number of tokens that are generated at each call of the model, or tweaking the temperature and other parameters. I saw that these kind of things were discussed previously in some of the previous workshops. So to check that, so this thing is only the description, the configuration for the LLM. To be able to execute it, I'm importing now Waveflow. That is the example of
a runtime adapter that I use in that demo. So I need to create a Webflow, an LLM given by Webflow using the Agent Spec loader of Webflow from that config. And then this LLM is something that can be executed and can be used. So here, just to test that the model works, it's quite slow because it's a local model running on my machine, but hopefully that works after a few seconds. All right. So I think in my previous test, the model had no idea what LauzHack is, but that's normal. It's a Llama 3.1, which is a bit old and trained long ago. All right. So the first thing I want to show in the tutorial is using an LLM node. And when you provide no outputs for an LLM node, it will simply generate text that completes the prompt that was sent to the model. But here, I want to extract information from articles. That's what the LLM node is about. So the prompt says extract relevant information from the Markdown article and passes an article. And then additionally to that, in the LLM node, I specify what outputs it should have. It should have an output, a title, topic, summary, outline, and author. Okay. So that's simply the configuration of the model. For testing it, I generated this dummy data of three basic Markdown styled articles. And that's what I will use to test this functionality. Here, I'm loading the 3 files. And then, same thing as previously, using the Agent Spec loader from Webflow. But it could be also the same with any runtime adapter for Agent Spec. And then, from this, we just start a conversation and we pass as conversation one article. And then we execute the conversation. And from this execution, we will get a execution status, which is what's the result of this execution. And the execution status will contain some output values, which I'm just printing here. All right, so we see that this output value, instead of simply sending a prompt and receiving raw text as an answer to that prompt, when we use this functionality, when we define with the Agent Spec the functionality of having multiple outputs for an LLM node, executing this LLM node returns a dictionary with the fields that were requested to the agent, to the LLM. All right, how is this happening in practice? Is simply modifying the prompt. The prompt sent to the model is not just this one sentence. There is also something wrapped around it that specifies what exact format to generate text in and specify these different properties that should be the output of what the model generates. All right, getting slightly more complex now. What I didn't show yet, I only showed one node and executed one node, but here we are now wrapping this node inside a flow. So there, just to define the inputs and outputs of that flow, I will create a start node and an end node. The start node, it has a single input, which is an article, will receive an article. And then the end node, it has these 5 outputs, which are the outputs of the LLM node that I showed previously. And here we create a basic flow with just 3 nodes. Start node, article analysis node, this is the previous node that I showed. And what we need to define extra is the control flow connection and data flow connection. So the control flow connection
here it's a very simple example with only one node. When there are multiple nodes, the things are more meaningful. But here you can simply say you see the basic things starting from the start node to the article analysis node, and then the article analysis node to the end node. For the data flow edges, here this is the one edges that takes article from the start node and gives article to the analysis node, and same thing. These 5 edges take the output of the article analysis node and pass them directly to the end node. Pretty trivial. And so one other things you can do when you have defined any component with a Agent Spec, whether it's an LLM, a node, or a flow, you can export it to its configuration. So with the Agent Spec serializer. So here, this is the same kind of JSON object that I showed in the slide previously, but it's complete. And with this JSON object, you see it's a component type. It has some IDs, the same name, etc., as what was defined here. Here I defined one name. Okay. Now that I wrap the logic from the previous node inside the flow can be used as a configuration for a map node. So here you see the map node that has this subflow, the flow for analyzing articles. And then this with the same with very similar code as the previous thing, the map node can be put into a flow. The difference now is that the inputs are not anymore the string property that we used before, but they are list properties. So we will receive multiple articles, and we will generate multiple titles, topics, summaries, outlines, and authors. So yeah. I didn't execute all the cells. Okay. So the same configuration, except that this one is now longer because it's the configuration for the the flow executing the map node, which the map node itself contains the subflow that executes the LLM node. And I start the execution. So in this execution code is very similar to the previous one. We use the Agent Spec loader to get a flow that we can execute, not just the configuration from Agent Spec. Then from this flow, we create a conversation. We call this object conversation because often this flow, they are agentic and want to be talking to a user, but it's not necessarily the case. And we pass it the list of articles. Then we execute, and from the output values, we just zip on all of the list of outputs to print the result. So, and here you see the article 1 had the data correctly extracted, article 2 similarly, and article 3 similarly. So that's all for flow. I will now demo the React agent with various tools. So the very similar code as what you saw on the slide previously. We define a server tool. The server tool has a name, a description, and then inputs. For this tool, I'm creating a tool that gets a country name as input and returns information about that country. But how this is happening is not defined inside the server tool. In the server tool now, we only define the metadata so that the agent can be prompted to make correct decisions whether to invoke that tool or not. Then the agent has a name, the configuration to the LLM that this agent uses, the list of tools it can use, and a system prompt if some relevant guidelines or indication for how to behave are needed. Yep. So here the execution for this agent is slightly, we cannot just load this component because we decided to use a server tool. We need to, when executing the agent with that server tool, is the agent that will be responsible to do the execution of the server tool. So to load that agent, we must specify what's called the tool registry and the implementation of the tool in that tool registry. If we try to load the agent without specifying a tool registry, there will be an error that the agent has this server tool, but there is no implementation for that tool, so it cannot be invoked. So here I just wrote a very short method. What this tool does, it could be an arbitrary implementation, like if you want a tool that does XYZ, as long as you can implement it, you can create that tool. Here I'm simply defining a URL with a country argument, and then using Python requests to make a GET request to that URL, and returning the JSON result as a string. So this tool is put inside the tool registry, and then when we load, we need to specify both the tool registry for to initialize the loader, and then we can load the agent. The code below here is what we call the conversation loop. Simply, we execute the conversation, which means that the agent will be generating messages or deciding to generate tool calls. Whatever the agent has decided to do, we print it to the console. Then we ask the user for an input. If the user said quit or exit, we stop the conversation here. But if the user said anything else, this input is appended to the conversation. And then we come back to the beginning of the while loop and we execute again. So the agent will do what the LLM behind the agent will predict what the agent does, and will make the agent either reply to the user or decide to make some tool calls. So when I run it now, it's executing the code at line 31, where we say user input equal, etc. The first message of the agent is simply how can I help you, because this is the first message of the conversation. There was nothing else to do. And here, because there is a tool to give info about countries, I can ask what are the languages spoken in Switzerland. So now the code is executing on line 23, where we run the conversation.execute. The model replied, the languages spoken in Switzerland are French, Swiss German, Italian, and Romansh. I think that's correct. But to show you what happened, I will quit this. And to see what happens, there was this first message, hi, how can I help you, from the agent? Nothing interesting. Then that's the message that I typed. And then what the agent did is, based on this request from me, the agent decided to invoke the one tool it has available, named get country info, and to pass as argument country Switzerland for the tool. Then this tool result is simply the result of having executed, because the agent generated a tool request, the process running the agent called that callable with the argument that the agent passed. And the tool result is the result of calling that callable, and this is the JSON result from the API. And from this, the agent was able to reply, the spoken languages of Switzerland are French, Swiss German, Italian, and Romansh. The next agent here is actually nearly the exact same agent, because I defined this time as a remote tool, doing a request to the same URL as you saw in the custom implementation of the server tool in the previous agent. So here it works similarly. The advantage is that because I define it as a remote tool, the call to this API is now part of the configuration. Previously, with the server tool, what's in the configuration is simply the metadata of the tool, and the implementation of the tool is could be anything and needs to be provided when we load the agent. Here, because I'm using a remote tool, these arguments, URL, HTTP method, they are part of the configuration. So simply loading that configuration, what happens here, is enough
to know that the tool is actually a web request to this URL. And that loop is the exact same code as in the cell above. So we can also ask arbitrary question about countries and see that the agent can reply. Apparently, Germany is at 52 latitude, 13 longitude. And I will quit this one again. Okay, and the final agent is a third implementation of a similar agent. To go back to the question that was asked, why not everything is an MCP tool? We actually can implement things such that everything is an MCP tool. I'll show you quickly a very basic MCP server that I implemented for that demo. Using FastMCP, it's a library that makes it easy to create smaller MCP server. And here I have a single tool, the same tool with the same implementation as before, except that it's marked as an MCP tool. And then this means that there will be a server running. In my case, the server will be running locally. That makes this tool available. And to configure the MCP tool on the side of the agent, we need to specify what is the connection to that MCP server. So here, specify the MCP server URL and the communication, how to communicate with that server. We specify the same metadata about the tool, and with the added things that this time we say which MCP client to connect to, and then the agent has access to this get info tool. Now I will start the MCP server. So when I start the server, you see a nice message saying it's running at this URL, which matches what I said. I showed it for a flow, but it's the same thing for an agent, that every component, agent included, they can be exported to this JSON configuration, which you see here. Also, in the previous cells, I was using a load component, but there is also the method load JSON from any runtime adapter. They can load a component directly from the Agent Spec SDK, but they can also load what was exported as a JSON. And here, this is the same conversation loop. And when this one is executed, when the agent decides to use a tool, we see that there is some activity on the MCP server because the agent told the MCP server what to execute, and the MCP server is responsible for doing the execution and then returning the result. And I'll stop here. Okay. So, and what happens is the same thing as with the other agent. There is a question from a user, and then the agent decides to make a tool request. Then the agent observes the tool result coming back from the API. And from this observation of the tool result, the agent may decide to make a second tool request. But in that case, the tool result was enough to reply to the user query. So the LLM intelligently generate the agent answers to the user. Okay, so that's well, for me, a quick wrap up. We saw how to generate structured data with an LLM node by simply specifying outputs it should have, how to execute a complex logic on a sequence of inputs using a map node. And then we saw how to develop these React agents that have tools and can decide to invoke them or not, either with server tool, remote tools, or with tools from an MCP. And we saw how to take one runtime adapter for Agent Spec and execute these Agent Spec configs. All right, if you want more, there are our GitHub repository and our documentation available. Thank you.